Hi, everybody. My name's Tom. Good morning. Has everyone had their coffee? I have. All right, so today I'm going to be talking about HTTP clients, specifically how I write them after doing this for as long as I have. Um, I want to start out. My name's Tom Lyons. I'm not Mat Ryer. Uh, there was a talk a little while ago by Mat Ryer, and I stole the idea. So here we are. So a little contrast between me and Matt. Uh, he has met Mat Ryer. I have not. Uh, He's a developer since 2006. I'm a youngin' still. I'm 2015. He has a refined British accent, whereas I have a smooth, sultry radio voice. He's handsome, but I am very handsome. Asterisk. All right. So the commonality between Matt and I is that we both have a talk based on an idea from Mat Ryer. So if you're not familiar, Mat Ryer is the author of How I Write HTTP Services in Go after 7, 8 years, depending on where you're looking at the internet. Um, so this talk was inspired by that, and I want to introduce kind of the same paradigm for working with HTTP clients. Um, it's going to be code. I'm not very good at making PowerPoint slides. This is the last slide. Um, so we're going to be talking about just general code. So, word of caution, take everything I say with kind of a grain of salt. These things are meant to be typable by me in this amount of time, and also just kind of give the general idea. I'm gonna make mistakes. I'm gonna do some weird stuff you should never do in production, but that's what we're talking about today. All right. So let's start out with a simple server. We're gonna be coding against a very basic server that just has a couple of endpoints. Um, so we have foo, we have bar because we're coders, and then we have login. Um, so very simple. Foo just sets the content type to application JSON and encodes foo as a hard-coded value. Same thing with bar, and login is the worst possible login check you could ever have. I work for a security company. All right, so the first thing we want to do, we want to code against a client for foo. So we have a handy little client. We've made a handy little foo method, and we're going to do this kind of the old way. So, or the normal way. This is the thing you write as a one-off. So if you want to have a request, it's simply request. Always check your errors. New request. We'll do the get method because I'm lazy. And we'll give it a URL. In this case, our client has a URL attached to it. So we just do that URL, and we'll give the foo endpoint. Because it's a GET request, we're not using a body, and so we'll return the error. And this will be very familiar throughout most of what we're writing is the kind of old, or the traditional way to write an HTTP request. And then we can take the client. For something I'll use later, I'll say C is equal to the client, and we're going to do C.do, and then we do our request. And that'll give us some kind of response and some kind of error. Again, let's just copy paste that over. And great, we have a response. We can check if the status is 200. Status code. Does anybody actually type anything, or is it just tabs anymore? We're going to check if it's not that. I can type. And I'm sure I have imports turned on this thing. Ah, VS Code. Should have used JetBrains. Shout out, they're here, and I apologized already for using VS Code. Uh, so we're going to go to our extensions in case we're wondering. I have it installed. And VS Code, you wanted me to redo this. All right, cool. Oh no. This is the worst possible time. Oh no. That's terrible. Okay, it's fine. I can do this extra hard. Hard mode, we're doing our own imports in Go format. It's so fine. It's fine. I know how to use the command line. It's just very, very small. I don't know how to use the command line apparently. Okay. It's fine. We're just gonna have to type very, very carefully and never import anything else. So we have our response status check. We'll try to, read the body. Um, Basically, all the response bodies are always going to be a. And now my imports aren't working. Oh my god. What was that? Line 33? 33. Oh, you guys are my own debugging. Thanks, guys. All right, so we're going to read the response body. There's a couple different ways to do this. Since we're returning JSON, we can, just read it as a JSON decoder. Something I like to do is actually to use the, I got to import IO. Okay, fine. IO dot read all, and we can read the response body. The reason I do this is basically if I want to return an error, like if you're expecting JSON and it gives you back the 404 status or something like that, it'll give that in plain text, not JSON. And the JSON encoder won't really reveal what the real error was. But if we first read it off into a buffer or into a byte slice, then we can use it a little later on for our errors. So if error is not equal nil, cool. And then we can do JSON dot unmarshal, and we can unmarshal B into some kind of foo struct. So we'll say foo, and we'll unmarshal it into foo. And because my imports are up here, I got to do this. It's a really good advertisement for JetBrains, right? Okay, and then I also need the coding JSON. All right, let's try to format that. Whatever. It worked. So we unmarshal the JSON. That'll also give us an error, and we do this error check again. You'll notice a theme here. We do a lot of error checks because we're in Go. If we want, we can also add in our body, yay wrapping. So we can say something like, the specific error, and then also add in some kind of, body quote. So error and string B. So this will basically allow us to, interact with, the body of our request. If it wasn't JSON, oftentimes developers will want to know, well, what was it if it wasn't JSON? Otherwise, you just get like, hey, the first character wasn't a bracket, and I give up. Okay, then from there, we can return foo. We're done. Awesome. Now, if we want to write this again, it's a lot of copy paste, which is fine. If you're writing 2 or 3 functions, copy paste is a great way to go. Copy paste is a tried and true method. The problem is what if you've got 100 different endpoints and they all have something in common? They all have a roughly similar, structure. So for that, we're going to add in some client decorators, some methods, kind of like middleware and servers, for our client to be able to interact with these a little more easily. So the first thing we're going to do, let's take out this status code and make it a handler. We'll have my client func m is for my client. Yeah, the auto end is back. And we'll say we want this to always require a status OK. And for that, we'll need to return some kind of method, some kind of client for that. Now, the HTTP library treats clients as a dedicated struct. What we need to do is change that to an interface so that we're able to basically extend it in the same way you extend a HTTP handler. So let's make our little client type. And that is going to just have the do method on it, which takes a request and returns a response. Okay, I hope that worked. I hope I didn't type anything wrong. This will be our interface, and we can make, we can check that the default client actually works for that by just doing the simple one-liner. And that will say, if we had a variable that was of type client, could that be the default client? Does the default client satisfy this interface? And if no errors come up, I'll assume it does. And then we also want to, in the same way that HTTP has handlers and handler functions, we want a client function. We want to be able to have a function that modifies how a client behaves. And that's just a very simple new type. We'll call it client func in reference to the HTTP version. And that's just a function with that same signature. And to actually have it implement this interface, all it takes is a little function f client func do. So that way, when we run this function, all it does is return f for the request. This is very similar to the HTTP server handler. If we go over here, we can pop into the library in a working VS Code. And it'll show you basically the exact same thing. It's a function that acts as a struct for implementing an interface. It's a function that acts as an interface for our purposes. So instead of having our client be an HTTP client, we're just going to have it be the interface. And that's okay. Back, if we assign our, default handler to this client, it'll work. No problem. We have our little main file. In here, we can say, my new client, we're gonna have a default client and give it an address, and it works. This is a relatively simple way to just implement it without any bells and whistles. But we wanna add the bells and whistles. We wanna have that decorate required okay. And we're gonna have it return a client function. So now we have our little client function, and just we want to check the response. We want to check to see, hey, when I run this, is my response status okay? If not, bail. It failed. We're not doing this anymore. And so we can just have the response error is equal to m. Sorry. We want to pass in a little client, and that's equal to c.do. So you do your request, you get a response, and if you have an error, then you don't have to check anything more. You already got the error. However, you can also, if you don't have an error, I'm just gonna copy and paste. Copy and paste is awesome. That's how we code everything. So if that's not true, return that error. Otherwise, return the response. Not the rep, the response. So now when we do this, we can take C is equal to my client, and then say C is equal to M, decorate required OK, C. So now when we run the do function, we already have this check in place. We can delete that. Our code gets a little bit simpler. In fact, when we initiate this, let's say all of these clients are trying to get 200 status OK. So we can put that in the base client. Instead of having that in every single function, we can go up to my new client, and we can say, m.c is equal to, require this client. So now every time we use this client, it'll check, did I get a 200 response status? We can do the same thing with the body. So it's a very common pattern where you want to read the response body, you want to read it as JSON, you want to, encode it to a struct that you pass to it. You want to give it a pointer and then deal with that. So we can do that exact same thing. In fact, I'm just going to copy and paste to avoid typing as much as possible. So we can say decorate, let's go with Jason and Marshall. So that'll take a client, and then you can also pass it in a pointer, some kind of thing. And surprise, generics in Go is spelled A-N-Y. Yeah. Uh, so in this case, we want to do all of that because we want to just copy and paste this kind of code. Now I've made a big error somewhere else, and I'll tell you about it. If I do this, it won't. Yeah, if I do this, we'll eventually leak memory. That's one of the dangerous things about just coding everything everywhere is like, let's say I copy pasted the code earlier into another function. I then realize that my foo function's leaking memory. It's leaking memory because I don't close the response body. And so if I had copy pasted the code earlier into the bar function, um, too bad. It it would have been another memory leak inside my bar function. Um, and I would have to go through all of my code that I ever copied and pasted, and I'd have to realize, I didn't close any of the response bodies, and I have to painfully do that. By having kind of a centralized area where you're doing these monotonous, routines, you can have a single spot where you can focus on where you need bug fixes. By the way, this could also panic. So, we're going to be good little coders if response body is not equal to nil. Otherwise, it'll panic because you can't call close on a nil response body. So yeah, so now instead of unmarshalling to foo, we're going to unmarshal it to some pointer. And that's it. So now all of our code for this do can be handled by C is equal to m dot decorate JSON and Marshall and foo. So we can add this not only at the end of the response, we can also add decorators for the beginning of the response. So if we go back over to um, our server, we have these handle foo, handle bar. What if we want to require that certain endpoints or all endpoints have a header? So if I have s dot, what did I call this? Yeah, that seems like a normal name. Require header. A little bit of background about this. All it is a little function where you pass it a header. This header has to be the request has to have that key in the header. If it doesn't, fail out. So we'll say, oh, we're going to require the header. Tom is doing fine. I hope I am. So we want this on all of our requests. We can copy that over. And now in our client, we want to be able to satisfy this because now if we run our client, it'll fail every time because it doesn't have that header. And so over here, we can do just another handler, another client handle function. So this is a way that you can manipulate the request before it ever gets sent out. So instead of decorate required okay, we're going to say add header. There we go. add a header, that's the key, and we'll say some value, which is also a string. So now in our request response, all we need to do is add request dot set header. That's what it was. Set header, H and B. So this is a very simple way to say, for all of our request response, we want to be able to m.c is equal to m decorate add header. And I forget what I called this. It's fine. Tom is doing fine. We're saying that. And we'll say false. Tom did not check his VS Code this morning. It's always prepare because the demo gods hate you. I was like, yeah, what's going to go wrong? I know how to type. So we add that header to all of our requests. Now, if we, have our foo, that will unmarshal into foo, and we can now copy all of this over to our bar, and bar becomes that much easier to implement because now all I'm really changing is the type that's going to return. Oh, none of you guys told me that. That was wrong. Anyway. Yeah. So that's a very simple way to kind of decorate clients. It's adding stuff before and after the response to be able to, get a more meaningful impact. What's also cool is that you can do this for a lot of authentication stuff. It's very common that you might need to log into a server, get back a token, and then that token gets used for everything. You can do that at startup. You can just go out to that server and try to get that token. The problem is that you may never use it. Maybe, at startup, you're not doing that API call or that set of API calls. Also, what if the server's down when, you're trying to get the token? You can keep retrying until you get it. But again, you might not even use it. We don't know until we actually run the program. So we want to be able to decorate requests with authentication kind of ad hoc on demand. So for that, we're going to add yet another decorator. There's a theme here. It's just keep adding decorators. And we're going to say, decorate add off. That's going to take some username and some password. And that will add in the auth. So the first thing we want to do is say, when we initially run this function, let's go out and check the server. So we're going to have a once. And this allows us that every time we call this, it will try and only do this once. So we will once dot do func. Man, that Go imports is really annoying when it's not working. So in our function, we want to be able to have a new request, or really just get anything back. So in our login server, the way it works is that it will, in our handle login function, it will check for the basic auth, and if it's set, it will give you your special token. So then we'll add that to the header for all subsequent requests, so that we can, require it for our various services. Let's pop back over to client. So in this, our request is very simple, so we can just use the get request. Oh, sorry. We'll need to set the basic off. HTTP dot new request method get, and this is going to be our URL or whatever your login endpoint is. Again, it's a GET request. We don't need a body. And if it doesn't work, we're gonna be good engineers. We're just gonna panic. It's fine. What's the word? It'll panic and prod. I don't know what you guys do. That's what I do. And we'll use the default client. The default client's a solid way to go. If you're not doing anything too complicated, if you're doing one-offs, do it. And again, if we get an error, be good engineers, we'll just panic. It's fine. And then we'll check, does this response have the token? So now for basic auth to work, we need to add into our request set, set basic auth. That's going to be our username and password. And then once we have our token, we'll be able to add it to all of our requests. So from here on out, this should be a variable defined up here, so we can reuse it in our later functions. We can say request set header, and our token is a token. All right, let's make that pretty, because reasons. Oh no. Fine. Overwrite. Cool. So what this does is, on the first time you call any endpoint, oh, sorry, I forgot to hard code the credentials in here like a good engineer. Add auth. We'll say that it's Tom, who's obviously accessing the system, and my password. This is a password. Password 1. Security. Um, in reality, if you're curious about how to actually add authentication, stuff like that, use secrets, for or however you're deploying it. Those are usually the best way to go. Kubernetes, Docker infrastructures, EKS, all that. They have the ability to add secrets. Those are your friends. So we're going to add the auth. So now all of our requests, the first thing, one of them, the first one will do is try to execute this function. And if it doesn't work, it'll panic. And that's sad. So we don't want it to do that every time. We actually want it to be able to retry. So if our server's down, we want to be able to say, this is not working. So let's do this in a different way. Instead of having this be a sync once, we're going to make it a channel. And it's just a channel with, empty structs. We'll have a length 1, and we'll say initiate it by just adding in an empty value. We do this so that we can kind of gate how this is operating. So in our, once, or instead of our once do, we can put in a select statement, and we can say, in the case that we get something off of the once channel, we're going to do all of this. Cool. The only problem is that now we'll only execute this once, and then every subsequent call will fail entirely. Again, not great. You can check though if a channel's closed. So like, let's say this succeeds. We just say, close once. We're done. We succeeded. We got the token. Great. Now, instead of while we're doing this, we can add in an OK. And so this is saying The OK is set to true when the channel is still open. If you close the channel, this will still execute this section, um, but OK will be false. So as a way to do this once, and once it succeeds, um, we can say, if OK, do all this. Now you might be wondering why I use a select statement. You don't technically need it, not for this. We use the select statement because requests can time out. If we have a lot of requests, maybe this authentication endpoint takes a while to actually hit, then we want to be able to say, you know, timeout. We don't want to spend all day waiting for it. Maybe we'll just retry. And so to do that, we can just use our request context. Yeah, not content, context. And we can check if, you know, that we have a timeout, in which case we can return the error on that timeout. And these timeouts are great because all of this is happening before we hit our server. So if you can time out a request prior to it even sending it to the server, that's a little less load on the server, and that makes our services a lot happier. And that's going to be request.context dot error. And hit save before we format. Great. So now we have authentication. We have a way for all of our endpoints to be authenticated when we need them to. We don't try it before we call any of the endpoints, but if we call foo, if we call bar, and they require authentication, we got it covered. We're good. Um, and that's great. But now we're going to hit our server as hard as we possibly can. If we send 10,000 foo requests, the server, assuming has some kind of rate limiting, and it'll rate limit on our behalf. And that's not a great experience because now we've just bogged down the server with unnecessary checks. Before it can even rate limit, it takes some amount of CPU for the server to be able to interact with the code before it sends back, hey, you're doing this too much, you're cut off. So in our client, we want to have the same thing. We want to be able to rate limit, what our client's doing. Guess what? We're going to add a decorator. Oh, you didn't see that coming. I appreciate that there's like 4 people just mumble laughing, like, yeah, just like that. Okay. So in my client, we're going to add a decorate rate limit. And for this, we're going to use a ticker. Go has a great solution for being able to do stuff within a certain time window or at a minimum sleep time. So time.new ticker. And instead of header values, we're going to say D for duration. And so this will give us a channel that basically allows us to rate limit. So let's say we want to have a certain number of messages within that duration. Then when we're in this little function, we can first just check if our channel has activated. So in here, we want to kind of have a rate limit. We'll call it limit. You'll notice I like using structs in my channels as opposed to like booleans or integers or something like that. If I'm not actually using the value in the channel, I don't want to spend the memory allocation for a single byte. So that's why I'm using structs, because that's what that allows you to do. So we make that the length of n. I misspelled limit. You guys are not helping at all. So within that limit, we're basically going to fill the channel at every time interval. So while every time our ticker ticks, we're going to say that we're going to add in stuff to our channel. So So what this does is basically, let's say every minute our ticker ticks. This will add in, 100 structs into our channel. And then when we go to actually decorate that rate limit, we'll do the same kind of select where we have the case of, the limit being met, or again, our timeouts. So now our client will either send the message within the rate limit interval, or it will, time out of its own accord. So again, this is not hitting the server if it times out. That's really valuable, especially when you're doing rate limiting. So if you say, we only want to send 100 messages a second or 100 messages a minute, um, our clients time out after 30 seconds because we have other logic to handle, those timeouts. We want to do something else. Maybe we back off, something like that. If we can do that, if we can do our own rate limiting without hitting the server's much happier. The server does a lot better. It performs a lot better, and that's really, you know, at CrowdStrike, those little gains are massive improvements. So I really want to emphasize, like, little gains. If you're writing a CLI, probably aren't going to make a big difference. Like, you can just kind of speed through it. The odds of your CLI completing before you run out of memory, super high. If you're, writing a service that is doing this a million times a second, like we do, um, then little gains make big impacts. So that's really, really what I want to emphasize. And that's how you write rate limits. So our final client um, can just be a very simple derivation of that. Time dot minute, and we'll say, we only want to hit it 100,000 times a minute. A low number at CrowdStrike. So I want to also emphasize, because I have like 5 minutes. There's a little timer down here. It's the get off the stage countdown. But I do want to emphasize a lot of this is useful for large scale data. If you're only doing the foo and the bar functions, write those directly. Go is a great language for just doing simple stuff and keep it simple. If you're doing abstractions like this, it is an abstraction. It might make the code, a little more complicated, frankly. Um, and you have to balance as engineers between, do I want, to save the implementation effort? Do I want to be able to say that all of my bodies can be parsed correctly, all of my headers are going to be there on my client, and be able to say that reliably? That's valuable if you're doing this in 100 different ways against 100 different endpoints. This is valuable if you're trying to expand your code base and have kind of a common core set of functions. It's valuable if you have a common API structure and you want to be able to unmarshal that in a common format. Um, but it adds abstraction, and it's up to you as developers to kind of toe that line between, am I helping or hurting? Don't go out and change your two function client to use this structure, because it adds abstraction, and you have to be kind of cognizant of that the easiest thing to do is have a function that calls no other function. It's got 20 lines. Every developer can understand that. What's hard to do is when you have 100 different functions that are 20 lines of all the same thing, and then you need to change it. And you can grep, you can use your bash skills. I have some, I guess. Uh, but we're gophers. We don't want to do that. We don't want to use bash. Gross. Yeah, the mumble laugh. That's what you guys do. I hope that translates on YouTube, because this is just going to be like me talking to an empty room and people will be like, But on YouTube, it's just silent. Like, as far as you can tell, there's two people in the room. Don't tell YouTube. So yeah, uh, that's all I have. That is my piece. That is my way of saying, go out and do stuff. Make your abstractions where you want, and where they add value to your organization. This is something I like. I write a lot of HTTP clients, so it became, very beneficial. But gophers are gophers, and we have a million different ways to do a lot of things, and 2 of them are correct. So yes, that is everything I have for you guys. Thank you so much.